go through a quick formula review. For area, you just do base times height here. So base times the height, and that's going to give you the area. Yes. Oh, the microphone, thank you. Okay, so we're just doing a quick review of formulas for area. These are all going to be area formulas. Well, I could copy it, but to get new words in there, I needed to type it. So that's the thing for a rectangle area, and it's also the thing for a parallelogram area. The thing is, height is what can be sometimes confusing for people. So the height, you always have to look for the square angle. So in a rectangle, it's really easy to find the square angle. Once you find the square angle, that tells you where the base and the height are. So that's the base, and this could be the height, which in a rectangle is the same as side times side. So for example, if this is 2 units and this is 2.5 units and we're in inches, the area is just 2 times 2.5, which is what? 5. And it's inches times inches. So not only is it 5, but when we do inches times inches, that's inches squared. Because it's how many little square inches can fit inside a shape.
So that's always going to be the unit.
That's always going to be the units on area. If you have inches, then you have area as inches squared. For some questions, Adam.
Are you going to find the volume of a cube?
We're going to do volume and surface area.
Parallelogram?
Oh, tipped over, it's called a parallelepiped.
Yeah.
We could. We'll be doing volume and surface area. So those are neat shapes. So for parallelograms, remember you have to find area, and area has to use height, and height has to make a square angle. So even it's best for some people to identify the base maybe with a highlighter, and then think about where can I put my height, because my height is basically the distance between the two bases. And it has to be straight up and down. So Johnny, what do you know?
Just make like a triangle with one of the sides.
Okay, so you could.
Where there's a.
You're going to come out here, right? That would be one option. So if you think about it, you could also have that in here, but you need, it depends, right? You need to have that height to make the square angle. Do you see that? So it's not one of the sides. All right, and does that make sense?
The side would be more than the height.
The side would be longer than the height. The height is the shortest distance between the bases, so that's why we make a square angle. But like Johnny's saying, it could be outside. So what you'll see sometimes, what you'll see people do is they will extend the line, but a lot of times it's a good habit to maybe make it dotted so you don't use it for anything, but just to extend the line out here. And then when you come up here to drop the height in at that right angle, can you see that back there? Your height, can't see it.
Can't.
You can. How about the rest of you? Is that better?
I can see it, it's just I can't really see the.
So it's going to be right here though, yes?
Yeah.
And so that is just making sure it would be at a perpendicular. Okay? So if you had to measure this with the centimeter ruler, which I'm going to have you do today, to find the area, you would have to know where to put the height. You'd have to draw it in yourself. And then you would take your ruler, your centimeter ruler, which is hiding, and you use the metric side, and I'm going to zoom in so you guys can see that back there. And then you would measure the base and the height. So to get a good measurement, I'm going to erase that thick yellow line. Now your going to use the metric, so I want to make sure you know that means the centimeter part. And then because the lines have thickness, today we just have to agree to do the same thing, so we're going to go from the outside of the line to the outside of the line. So the base, if we zoom in, see what you guys see back there, looks like the base is about
3.7.
3.7, that's right. So the base is 3.7. So we're going to record the measurement here. And then you have to go to the height, wherever you put your height, rotate your straight edge. And then we need to zoom in again and record, review. Here we go. Find that measurement, same thing, and get the height. So it's about 3.7. Coincidence. Okay, so, well, it's, no, it's just a coincidence that the base and the height are the same here. That was just a coincidence.
It's because you did it so perfect.
Yeah, so these are both in centimeters. And so then, you guys see that back there? So to find the area, you do 3.7 times 3.7. So 7 times 7 is 49, carry the 4. 3 times 7 is plus 4, 25. Put a 0, no decimal. You don't put a decimal in until the end. Okay, so 3 times 7 is 21. Carry the 2. 3 times 3 is 11. Add 9, 6, 3, 1. There's 2 digits after the decimals in the problem. Yeah, and you should know that just by estimating. It should be less than 4 times 4. Right? So it couldn't be 136.
Can't be more than 6. Yeah, it couldn't be 1,000.
Yeah, right. So you should know. So the area is here 13.69 centimeters squared. Okay, so far? Okay, so for triangles, and then we'll stop and do trapezoids later. Remember that triangles, if you clone a triangle and rotate it, together, yeah, it makes what? A parallelogram, right?
Where?
Do you see that? Do you guys see that?
Yeah.
So the area is almost the same as a parallelogram, except for we have to divide by 2. But we still have to figure out where that height is, right? So we still have to identify the base and then make sure we use the square angle for the height.
Is that a scaling triangle?
It is a scaling triangle. So we're going to, because none of the sides are the same. So we want to make sure we use the height, not a side for area. So if this were, let's say, 8 inches, and this maybe was 5 inches, the area, if we use this formula, base times height divided by 2, is 8 times 5 divided by 2. So that's 40, right, divided by 2, which is 20, and the units are inches squared. Okay? No matter what kind of triangle, does that make sense?
Yeah.
No matter what kind of triangle, if I clone it and rotate, I can always make a parallelogram. So I'm always going to be doing the same thing. But remember, on this triangle, if I have one like this, my base is here, but the height is going to be outside again, right? So that means even in a triangle, you have to use the height that's outside.
Yeah.
So then you would, let's say this was the height here. It should line up with the base. So let's see if I drew that. Okay. So pretty good. Remember, it should have a square angle. Whoa.
Whoa.
And have that arrow. Square angle here. So you would only use this part of the triangle because the other yellow part, that's not the base. This part over here, just this part. So maybe that is 3 inches and this is 4.2 inches. To get the area of this, you would do 3 times 4.2 divided by 2. So what's 3 times 4? And what's 3 times 0.2? So this is 12.6 divided by 2, 6.3. So the area is 6.3 inches squared. Does that help? Kind of a summary? We'll do trapezoids tomorrow.